What's going on, guys? Mr. Allen here. We're about to solve this system of non-linear equations. What kind of equations are we even dealing with if they're non-linear? Well, that top one there, that's a hyperbola, right? It has a positive squared term and a negative squared term. Now, that bottom one there, they're both positive, but different coefficients in front of each one, which then makes it an ellipse because it's going to be elongated in some way and not a perfect circle. Okay, so we've got that out of the way. Now, how are we going to solve this thing? We got three options: graphing, elimination, substitution. Now, I'm going to choose elimination for this particular one, but we could do substitution or elimination. I kind of stay away from graphing with these unless I'm popping out that, TI-84 plus graphing calculator. Okay, let's get after it. All right, so in order to do elimination, I need to multiply one of these or both of them by some particular number. I'm going to multiply that top equation by a positive 2. All right, and that's going to cancel out my y variables. So I will have 4x squared minus 2y squared equals 46. So this guy's gone, and now I'm just working with those two. When I add, my y's cancel. I'm left with 5x squared is equal to 80. Now to solve for x, I'm going to go ahead and divide by 5 on both sides. I'll get x squared equals 16 square root, and I get x equals plus or minus 4. All right. So when I do these types of problems, I like to set aside some ordered pairs. Now, I'm not going to say one ordered pair with a plus or minus 4. I'm going to have one that's 4 comma something and one that is negative 4 comma something. I do not like to put the plus or minus because then if I get two other solutions, which one goes with which? It's not very specific. It's a little ambiguous. So we're going to have two ordered pairs, 4 comma something and negative 4 comma something. Now we need to figure out that something by substituting back in. We can work with either one of our equations. I'm going to go with the bottom one. Let's say we have x squared. Let's write it down again. Plus 2y equals 34. 2y squared. Reason why I picked that one is because everything was positive there. I didn't feel like dealing with the negative. Okay? That's just me, man. That's just me. So if I plug 4 in, I'm going to get 4 squared plus 2y squared equals 34. So I'm going to have 16 here. 2y squared equals 34. And if I subtract 16, I'm going to get 2y squared equals 18. Divide by 2, and I get y squared equals 9. Square root on both sides, I get y, not x, y equals plus or minus 3. All right, so when I plug 4 in, I get plus or minus 3. Cool. Now, I can do that for that one because that's saying it's 4 comma 3 and 4 comma negative 3. Now the next one, let's do another color here. The next one I'm going to plug in negative 4. And if I use that same equation, I'm going to have negative 4 quantity squared plus 2y squared equals 34. Well, I'm going to end up with the same exact next line here, aren't I? There we go. I got the same thing. So should I get the same answer? Absolutely. We're going to get y equals plus or minus 3. So I have negative 4 comma plus or minus 3 then. So I actually have 4 possible solutions here. How the heck is that possible? I think it'd be helpful to take a look at what these general sketch of the graph would be. Now, the first graph there we said is a hyperbola, right? Now, it's opening left and right because it starts with it has a positive x squared. So it's going to be opening left and right, and I'm not even going to really get into the whole graph here and all the asymptotes. Just a rough sketch, okay? It's opening left and right. That's all we need. Now, the next one there, that's an ellipse, right? Now, for that ellipse, if I were to divide by 34, I'm going to have a larger denominator under the x, which means it's going to be larger in that x direction. All right, it's going to be smaller going up and down, but it should look something like that. Okay, maybe not as poorly centered as I have it. But as we can see there, we have the potential for 4 solutions, right? At negative 4, it's at positive 3 and negative 3. Maybe I'll do the orange marker for that instead. There we go. Positive 3 and negative 3. And then with that pink one there, we're at 4 and then positive 3 and negative 3. So we can see where it could cross 4 times. It makes sense, right? There's a potential for no solution still with this if the ellipse is really small. There's a potential for 2 if it's touching at the vertices. I mean, we got a whole lot of potential for different situations, but for this particular one, we got 4 solutions. That is it. There's my 4 answers. All that needs to go on the answer line if you want to get full credit. That's awesome. I hope you guys have a great day. I'll see you later. Deuces.